All right. I'll say a very good evening to everybody. This is the Front Range 6-meter group Zoom. And tonight we have the honor of hearing from Dr. Scott McIntosh, who to give us some information about what's going on with the sun right now, that we're between cycles, and lots of activity going on as far as RF is concerned. So be interesting to see if you can shed some light on as to why the sun is being so active lately. So with that, I'm going to throw it over to Scott.
Oh, here we go.
Sure. And good evening, everyone. It's been a while. It's been like 5 months. So it's amazing. It doesn't seem that long. I think the last time we spoke was in November. So uh, things have advanced a wee bit. So I'm going to put these up if I can find my window. Let's see if I can see. All right. So it's a similar title to the last talk. And I've updated a lot of my slides. So some of you have been following along for what? It's almost maybe more than 2 years now, Paul, right?
Yeah, been a while.
Since COVID, right? So it's been a while.
Yep.
And so, many of you know that we're past solar maximum now. It's not, I don't think that's a debate anymore. But that means that we're in the fun time, as Paul said, between two cycles. So it sounds like it should be a book by Emily Bronte, right? Between two cycles. Uh, and that's creating some fun. So maybe we'll get to that later on. I don't know if it's necessarily fun for ham radio. You get a nice baseline of a hot atmosphere for but it means that there's very frequent geomagnetic disturbances. So let's see if any of our prognostications kind of hold out. So by all means, stop me as I'm going through. You may see some new graphics that we're testing um, in the process. One of the things that's pretty interesting is we probably don't need to measure the sun. We just need to measure the number of deorbiting satellites from LEO to get an idea of what the solar cycle looks like. That's a new feature, right? So indirect observation, of course, because one of the things that we do, we're trying to help prolong the lifetime of objects in low Earth orbit, right? And so understanding the drag, the environment, the atmospheric drag environment is really critical to maintaining that life. So you can see from the plot that I put on here that this is all satellites that have deorbited in the last 5 years, 5 and a bit years actually, and you can see that it tracks the solar cycle really pretty well. That's a blessing and a curse, right? The idea being that the radiation from the sun's atmosphere basically heats up, not heats up, but it starts emitting more photons in the ultraviolet and X-ray wavelength ranges, which heat the upper atmosphere, which then expands, which creates increased drag for things that are flying, a few hundred kilometers above our heads. And so if the intensity of that heating gets large enough, it can even deorbit spacecraft, right? So that's one of the things that we are working to try and alleviate. We won't be able to eliminate it, but we'll try to alleviate it. So, and the sketch on the left is something I made it last weekend. It's kind of like a waterfall diagram and goes in layers of complexity. And you'll see you've seen these things over the years, and I'll talk about them, but it really goes from amateur to mega pro, right? So from my 7-year-old golfer to Rory McIlroy from top to bottom, right? Um, so one of the things we've talked about a lot in the past are these hail cycle termination events. And this is a diagnostic. This plot here is layered. Like this is a 7-bean dip of a plot, right? Has the sunspot number on there, has the sunspot butterfly diagram on there, and there's these red and blue things, and those mark out the locations of filaments on the solar disk. Believe it or not, these are the highest latitude filaments of any given rotational period. And if you strain your eyes, you see that the data set actually starts in 1860, right? So it actually coincides with the start of the use of photographic plates on telescopes, right? So the first observations came from actually from the Arcetri Observatory in Italy, and this is now a combination of multiple things. This plot was made in 2019. Um, if I add the recent data, you see that there's even events that we weren't really focused on that happened. So I mean, the whole point of this useless plot here is just to illustrate that this magnetic hill cycle does repeat and repeat and repeat. So it's almost like me coming on with you guys. I just repeat myself continuously. So um, just to show how nested this problem is, I think I've used this one before, and the idea of how the sunspot cycle is really just a subset of a much larger thing, this magnetic cycle, right? So we're kind of building a narrative, but that narrative is very different from anything you will catch out there in the wild. This is a combination of goodness knows how many plots. So like the waterfall diagram, there's sunspots in there, spatial distribution of coronal emission, we'll talk about in a wee bit, and filaments, and they all follow the same pattern, right? So the challenge for us now is to figure out where we are in this pattern. Because once we know where we are in the pattern, we can probably, with relatively high accuracy, tell you what's going to happen next. So, how's our forecast doing? So, you've been tracking this along with me in real time for a long time. I'm now significantly grayer than I was when I started doing this. But you'll see that in this data plot, the forecast values in red, the thick line, and then it has 1 and 2 sigma error bars around it. The orange data there is the monthly smoothed sunspot number. So that's actually what we should be measuring against. And it clocks in at about a 0.77 skill score, which is actually very, very good. That basically measures the quality of the data relative to the mean squared error, right? So that if you were to calculate a mean squared error between the forecast and the observed, 0.77 is almost like a correlation coefficient, if you like. And you'll see that in recent months, as the white data points that you see towards the very end, you'll see that it's really settled down around the forecast. It's like this is either incredibly lucky or very insightful. You can take your pick. I'm okay. I'm totally open to it being either. You'll remember that we start to play. We've been looking and analyzing statistics of a lot of things, right? And so this is the best way of comparing where we are in the magnetic Hale cycle, right? So this helps us anticipate what's going to come next. When I talked to you in November, this was the update. This was where the cycle 25 spots were relative to the historical average. That's where they are today. Turns out that I wasn't actually plotting all the data back in November, but now I am. So if in case you worry, but that's a little bit more than 5 months of data between the two. It's significantly more than that because I had a glitch in my code. So anyway, you see that what that basically means is that the butterfly diagram is, as we anticipated, adhering to what we thought actually. In November, this was what our statistical model of the solar cycle was looking like. And there you go. You add the other 5 data points, and guess what? It still looks the same. In fact, I think it's settling in even better. But those of you that remember being here before, the vertical lines in this thing are actually indicative of phases of activity, right? So things you can see clearly solar minimum in there. possibly the next Terminator event. You can see the fact that the sun's going to do some weird stuff in the next couple of years. We'll talk about some of that. You'll remember the probably the bad thing for you guys is what may happen in early 2028, which would be the fact that the solar flux will drop below 90 SFU and your ability to communicate globally will just go away. Right? Possibly, with the exception of maybe large heating events that happen. We call this the activity cliff, but that also means that there's no flares, very few CM coronal mass ejections, and anything else. Then you got to wait for another 5 years. Thereabouts, 4.5. So things are tracking very well. If you remember, we talked about the overlap of 2 cycles the last time because when it comes down to it, there's actually 2 magnetic hill cycles. Almost not always, but the majority of the time there's 2 magnetic hill cycles present uh, on the sun. And at least our hypothesis is that they fight with one another, they tussle with one another. And at the risk of using a very kitschy analogy, you get the light side and the dark side. And what we're seeing right now is the fact that the dark side is starting to interfere, right? So we're starting to see a lot of coronal holes. You're starting to see a lot of auroral activity that comes from um, coronal holes, so from the fast solar wind. So you've got the activity belts producing one frame of activity, and you've got the coronal holes producing another one. So you've got almost like an amplification of space weather at this moment in time. This is all kind of irrelevant, I think. And you'll remember that we called this thing the battle zone the last time we talked. So you're really seeing the overlap between the two sunspot cycles or the two hail cycles, and that's actually driving a lot of the amplitude changes that we see. Also, pretty bad for you guys is the KP index. The KP hasn't gone bananas yet, although it's rising. Don't ignore those red data points. There's something spurious going on in there, but you can see that the green points are indicating that the net KP index over the course of a month is going up. That's exactly what you would anticipate in a situation where you've got competing sources of space weather going on. So, and you can see that the variability, the variance in this time frame after solar maximum and before the activity cliff, the deviation, the variance and the amount of geomagnetic activity is huge, right? I mean, look at the size of the sigma bars on this thing. They're massive. Okay, so again, just framing it in the context of activity, just to illustrate that this isn't a fluke. Here's the historical data put in context. And the top plot here is the monthly average AP index. So that's a globally measured geomagnetic index. And you can see that in the declining phase of cycles, it actually peaks. It's enhanced, right? So it's the same thing. There's no mystery of what's going on right now.
He's
But mhm.
the chart before this. You had there was like kind of a light, that light gray line that goes all the way up to the top. What is that?
Which flight railing?
Well, there's a.
Can you point me to it?
I don't know if I can point it, but yeah, you're almost there. Okay, yeah, go up to the top there. You can see it. There, yeah, that thing. What is that?
This line here?
Yeah,
That's the envelope of the geomagnetic activity. So that's like 1 sigma, right? So the variance. So if I look at the hundred and well, the geomagnetic indices go back to 1860. So if I look at the variance, so if I basically what you do is you construct a statistical model for that phase of the magnetic cycle, Paul,
yeah.
and that is the range of variability of the geomagnetic indices in that time. It's massive, right? So it's like 1 sigma, it's one standard deviation. It's huge. So what that means is you get these colossal events that happen in this time frame.
And that looks like it's going into next year, 2026 is
Yeah.
where your
Uh-huh.
peak. So what you're telling us is it's going to be uh, a lot of
Well,
variability going on.
we're already seeing it. In fact, it's happening today, right? So I don't know if we'll get Aurora down here tonight, but Europe got a great show earlier today. There's a huge substorm that was driven by uh, a combination of a filament eruption and a coronal hole. So we actually were probably right now, we might still be in a G4 storm going on. I don't know if it's affecting propagation, but uh, yeah, we're going to have some fun. So I anticipate that as I start to look at this plot now, so again, the green line at the top is the geomagnetic index. As I start to look at this, it's actually going to show that it's enhanced. Um, we're going to see it jump up to where it was probably in cycle 23 time frame. So in that 2002 to 2005 range, it'll be enhanced by maybe about 50%. So we'll see. We won't cover this. We talked a little bit last time about the polar magnetic fields and how I think in November it was still the jury was out a little bit that whether the poles had actually reversed. Well, it seems like yes, they reversed in the middle of last year. So that means that solar maximum was there or thereabouts, middle of 2024. It's always one of those things that's easier to define after the fact. And so one of the things that we're looking for next is to track this the Rory McIlroy of diagnostics, right? So this is looking at the shape of the sun's corona, right? It sounds very esoteric, right? But it turns out that the shape of the sun's corona gives you a beautiful measure of the Hale cycle. Okay. And so there's some illustrative examples of it there. The question is what comes next, right? So again, you can play the statistical game. You build up an average. Um, this is where we were. And yeah, lo and behold, you add 5 months to it, you get that. Look at that. Did you see that? Hold on. Sorry. Look, add the data. Oh, there you go. That's it. 5 months. No sleight of hand, right? So it's still tracking, but what we're seeing a lot of evidence now of the northern polar coronal hole starting to open, right? So make make take full advantage of the enhanced solar radial flux for the next year and a half, right? Because once that polar coronal hole opens, the solar radial flux drops by about a third. Okay. We'll talk about that when we turn the recording off. So, so again, now I'm being a little bit cheeky, and the evolution of man, it's like the evolution of a solar physicist, right? Or something, if you're dealing with just the sunspot number, you might be a primate. But as you go up in sophistication to the Rory McIlroy of, it's very topical given the weekend's events. Probably nobody gives a toss, but um, you're now looking at a very fully formed diagnostic that can help you understand what's going on. And again, um, so I'll leave it there. I know it's a very quick update, but does anyone get any questions? Because I don't know I know many of you have been following along, um, some more than others, but I'm happy to answer questions just now.
So so it looks like your forecast, looking back your previous chart for this, your forecasted of this particular cycle was uh, spot on compared to the ones that came from NASA and all the other folks.
Well, I mean, with the provision that we had to modify ours, right?
Yeah,
So yeah, so once the Terminator event happened and we could freeze the forecast, yeah, it's exceptionally good. Yeah, and so, for comparison's sake, the consensus forecast from the NOAA NASA panels, they're in gray, right? When we turn off the recording and I show you how it looks in the longer time scale, of course the two of them start to agree better in the declining phase, right? The problem is that all the damage has been done in the ascending phase, right? So I don't know. They have a new product out there that's pretty cool. Um, but it adjusts every month. So I'm not sure. I'm not sure that that's actually, part of the puzzle here, um, is to try and understand. I think if you can replicate the behavior to this level, you're getting to a point where you might actually be on the cusp of understanding what's going on, right? But if you have to adapt your forecast because it doesn't fit every 3 months, then that's not really fair, right? But it depends what your objective is, right? If your objective is to understand, then you've got like 5 years of it looking pretty good. I'm okay with that. But we're not adjusting this every 3 months. This hasn't changed since December of 2021. So yes, it looks pretty damn good.
Hey, Scott, a question about satellite deorbit chart. Is
Yeah,
that normalized for the total number of satellites or the number of
no,
launches?
no. So that includes Starlink, and so it's basically everything that it doesn't include debris, and it doesn't include rocket boosters, because of course the number of rocket boosters falling out the sky is increased as well, right? Because there's more launches. So all these things get cataloged. So this is basically, um, all of the low Earth orbit satellites
Okay,
that
thank
we
you.
orbited. The total numbers in that 10,000, between 8,000 and 10,000 region. So, but if you want to do some mental arithmetic and say that the cost of one of these minimum is $5 million. So let's say you've got an average of 25 of them falling out of the sky every month. The math gets pretty impressive, right? Any other questions? Apologies, Paul. I went through that really quick. So,
you did good.
yeah, again, I don't know who's been following along since the start. I don't want to bore everyone by going back to step one.
They can look up the videos we've got online. Yeah. Come on, guys, you guys must have some questions.
Hey,
There's
Scott, what are the chances of another large peak in the high 190s or 200 range by November? What are the chances?
For the fall.
Yeah, for the fall.
It- I can't discount the possibility of another surge, right? So, like the thing we had last fall.
Have we seen two, what you could call two peaks, one in the northern and one in the southern hemisphere in this cycle?
Um, we've had a number of peaks. So yeah, and it's kind of weird because there's two things that are driving hemispheric asymmetry. Let's see if I can find a good example. I might have to actually, if you look at this plot, so now look at the middle, right? So if you look at the middle chart in this thing, it's red, blue, and black, right? So red is the northern hemisphere, blue is the southern hemisphere, and black is the total. And what happens when and we kind of cheat a little bit here. We take a 100-day moving average through the data. And so it smooths it out. But you can see these massive excursions that are in the data, right? So you get these huge peaks. right? So the decadal envelope is maybe about 50 sunspots per month, but then there's an oscillation that pushes that 50 up to 100. So if I draw your attention to early 2012, it might be the easiest one to see. You actually have a southern peak and a northern peak at the same time. And so the amplifies the total sunspot number to like 140, right? And so part of the challenge we have is the two hemispheres themselves are not always in phase. So that's the thing that I would normally associate with a double peak cycle. But on top of the double peak cycle, we also have this other phenomena that is producing these surges of activity. In fact, there's, eh, this is not current. I can pull up a current chart when I shut down my thing. You can see that there was the last fall, it was a big surge in the southern hemisphere. So that might end up being the peak of sunspot cycle 25. But the north has not reciprocated yet. If that's a long way to answer your question. So there's every likelihood that there could be a large surge in the north, that would then increase the radial flux to a point where you're up in that 190 to 200 consistently. I wouldn't bet against it, but I think it looks like we're very much in the declining phase now. So I can't, it may well be that the decline and a surge offset one another. So you would just set about the 170, 160, 170 kind of range, which is still pretty good for propagation. It's not mental though, right? So, sorry, Scottish.
It's good for 28 megs for 10-meter band, but for 6 meters,
It's
we
pretty
need
poor,
something
right?
up near the almost near the 200 mark for F2 propagation on 6.
Yeah. So
That's east-west propagation.
I
We're
can't
always going
bet.
to get the trans-equatorial during the equinoxes, and we're
Yeah.
getting some now. But
Yeah.
the east-west requires that much higher solar flux numbers in the 200 range for us to get that kind of propagation, at least from the northern hemispheres. The fellows down in Florida, in the Caribbean, they're in a different world. They get some great propagation that we up north can just dream about, never see it, or
Yeah.
rarely see it.
Yeah. I can't, I can't guarantee you, right? So that we might be off of that peak by now. So, but you see, it's not if you look back at the last cycle again, there was a 2 year separation between the northern and southern hemispheres, right?
Remember that, Roger?
So, and cycle 23 before it was a little bit more synchronized. So, and really, to be honest with you, Rich, that's all it would require is to have a surge in both hemispheres, right? So if the two hemispheres ganged up and both had a moderate surge at the same time, then you could get up to those numbers for 6 months. Now whether that falls in the fall or not is a different story, right? So if I knew that one, yeah, I'd be loaded. So does that answer your question?
Yes, it does. Thank you very much, Scott.
No problem.
Who else has got a question for Scott while he's here? There are no dumb questions. Remember that.
Yeah, no, definitely no dumb ones. You guys know a lot. You guys know a lot more than I do. So
That'll be the day.
I'm a one-trick pony, Paul.
Yes, well, you're a good pony. Not a lot of horse shit, that's for sure. Anyway, um, did you have something else you want to do, or like turn off the
Hold on,
record?
I'm seeing. Yeah, I got a couple of extra slides here, but Did someone post something in the Zoom?
Those are a couple of questions. Let's see, or points. Um,
I can't pull them up. I have
okay,
no idea where my cursor is.
that was from Jason. What was your comment there, Jason? Maybe he's muted. I don't think we can't hear him.
Okay.
All right. And he was saying the Miles Mathis planetary alignment model has a peak in February 2026 for the Saturn-Neptune alignment, and then again in 2026.
Oy.
Yes.
Yeah, I actually had an exchange with someone talking about that. I think we may have even talked about it back in the past that
Yes.
very hard. You can't just have one peak and one trough. There's lots of peaks and troughs, right? And I as much as I love the elegance of tidal forcing, I just don't think that the primary driver of things like the solar cycle are gravitational tidal forces. Not when you have, that's a very weak force compared to rotation. You get an object the size of the sun rotating at its rate, that's a massive source of energy. And so I could see actually long range planetary alignments and things actually helping to synchronize subtly, like really subtle things. But then you'd have a hard time picking out all the various resonances in the solar system, right? You'd have a very hard time taking that out of just random noise. So I don't know. It's beautifully elegant, and you would think it would make sense. But, prognosticating that there's a couple of peaks going to come up, the chances are there's going to be a couple of peaks coming up, right? So, because the sun has Rossby waves and they love an 11-month period. So, chances of you being right are pretty good, actually. Whether you get the underlying cause of the peaks right is a different story. So, again, beautifully elegant stuff, but I'm not sure it applies to the sun.
Okey-doke. I'll turn off the recording, but thank you, and I'll let you.
Yeah, I've flashed it a couple of times now.